Hi and good day everyone. My name is Zul Akmal bin Abdul Ghani, number matric CD 20075. Today I want to present about lathe machine. Lathe machine are one of the oldest industry machine in the manufacturing industry. Lathes operate by rotating a cylindrical object, commonly metal workpiece such that a tool may cut into it to produce a uniform axial pattern. The workpiece rotates on its axis but does not move in any other direction. The cutting tool is the moving part that advances along the path of the strike cut. The lathe is quite a versatile equipment. With different attachment and slight modification it can be made to do operations such as turning, tapering, screw cutting, facing, knuckling, drilling, spinning, grinding, polishing and boring. Operation Analysis Ball. Step 1. Pick a standard turning tool to create a semi-square shoulder. If there is enough material behind the cutting edge, the tool can also be used for rough. Step 2. Pick a standard turning tool with a lead angle. This angle enables for heavy, rough cut. It is also possible to turn the tool to create a semi-square shoulder. Step 3. Nose has a very large radius, which helps with fine finish on both flat and heavy cut. The tool can also be used to form a corner radius. Step 4. Pick a rotate standard turning tool. Its nose leads the cutting edge to create light finishing cut on the outside diameter and face of the shoulder. Step 5. Pick a form tool. Different form can be ground into the tool, which will be reproduced onto the part. Step C. Pick a 16 degrees strip tool used to trick stock.
Hi, my name is Nabil Fikri Saifuddin, and today I will present about the flow chart and C code for Lathe machine. Okay, the first one is the flow chart of Lathe machine. Okay, we have a start, and next we have to insert proceed or cancel the proceed brought by Lathe machine, and then we have to insert the working hours. And for working hours, it must less than 8 hours. Next, we have to insert 5 different value of width, height, and thickness of workpiece, following by the diameter of the workpiece surface before machining. And for the diameter workpiece, the value must be between 10 until 280 millimeter. And for the speed range, yeah, and then next we have insert the speed range. Same here. We must for the speed range we must have 25 until 1600 rpm. Next we have to insert the infeed depth. For infeed depth must less than 19.05 millimeter. And then next we have to insert the treat range. The treat range value must be between 0.4 millimeter until 120 millimeter. Next we have a fit to insert the fit range. For the fit range must not more than 2.0 millimeter of a revolution, and then we have to insert the cutting edge. And then next we have a output for speed used for cutting, pitch used for thread, depth of pitch used for thread, time used for lathing, and power used for lathing too. And then next we have a cutting for lathe, and the solid waste generate, estimate productivity, estimate solid waste generate, and total operate cost, and it will be the end. Next one is the discussion of code and run software, which is C code. Okay, this one is the programming or C code for lathe machine. So in this code we have include studio.h, include math.h. We have a integer, float, and we have a if else and for return or no return also have, and then we have a do and while. We have a scanf and a printf in our Lathe machine programming. Okay, this one is the result of Lathe programming machine after running. So we have this. We have the insert of menu, insert the result of insert the result in menu. We have a result here. So that's all for me. Thank you.
Hi, my name is Jillian Farhana binti Jamil. My friends and I would like to present about milling machine. For introduction, milling is a machine-operated operation in which the cutters revolve to remove materials from the workpiece in the direction of the angle which the tool exists. Milling machine may be used to conduct a wide range of operations and activities, from small to huge things. Milling machining is a popular manufacturing method used in machine shops and industries to create high-precision products and parts in a variety of forms and sizes. Milling has two types of machining, which is vertical and horizontal. First, we take a look on vertical. Vertical employ long and thin cutting tools, suitable for milling more pieces with more details and less expensive to purchase. However, they not as quickly to work as horizontal milling. This is a picture of the vertical milling machine. Next, horizontal milling employ shorter and thicker cutting tools, good for cutting deeper and heavier grooves into the materials, more difficult to find and more expensive, but they can save the money in the long term because quick processing time and low staff attention requirement. This is the horizontal milling machine picture. Operational steps. First, attach the cutter to the machine. The machine must be unplugged for safety reasons. Align the cutter with the workpiece and tighten the work to the spindle. Adjust the depth of the cut by holding the handles and pushing the motor housing down. Because the cutter runs at high rotating speed, the workpiece must be securely fastened to the table. Then turn on the milling machine and start cutting. Direct the machine slowly and advance it down with care. The cutting path must be continuously and uninterrupted so that nothing can obstruct its progress. When operations are finished, first remove the cutter from the workpiece and then turn it off. When finished, unplug the machine and turn off the motor.
Hi, now I want to talk about flowchart of milling machine. First, start the machine and then insert the working hours, foot range, spindle speed and the length of raw workpiece. It must be below than 400 mm. If yes, you will get the next step that insert the width of raw workpiece that must be below than 200 mm. If yes, the height of workpiece must be below than 300 mm. And then insert the length of thickness and length of F milling, and the equation is same. It is I equal to 1. If both say yes, we will resume the milling operation and then insert the operation hours and get the total energy consumption and the productivity. After that, the total energy consumption must be below than 200. And if yes, the commercial by total commercial 1 and 2. And it is also same to industrial. We get the industrial 1 and 2. And then The next, we will get the cost of elasticity. We display and get the total cost. And lastly is N. Okay, now I want to show you the input and the output of milling machine. Okay, first, this one is the input of milling machine. Okay, now I want to show you the output of milling machine. First, insert the working hours and then feed per tooth and the spindle speed, suitable feed range, height of workpiece, length and width of workpiece. Next, I will insert the flange thickness and the web thickness. It is same, I will put it 10. After that, I will input the number of cool required to milling workpiece. I will put it 2, and the first diameter is 15 and the second diameter also 15. And lastly, we get the milling analysis and the result analysis.
My name is Fatin Amirah binti Yusof. I will present about drill machine. For introduction part, a drill press is another name for a drilling machine. Drill presses make circular cross-section holes in solid materials using a rotary cutting tool or a drilling tool with cutting edges at a point. This cutting tool is spun and fed into the job at different speed and is held in the drill press by a chuck or mouse stepper. Other drilling machines operations include countersinking, boring, spot facing, reaming, and tapping. To produce a suitable completed product, drill press operators need practical skills and an apparent attitude to set up the work, speed feed, and give coolant. For operation and analysis, we decided that the drilling machine will operate on blind flanges. Blind flanges are used for terminating or isolating piping systems, and blind flanges are essentially boltable blank discs. When installed properly and combined with the correct gaskets, they can achieve an outstanding seal that is easy to remove when needed. All dimensions are in millimeter. As we can see from the side, the table shows the dimensions of blind flanges.
Next, flowchart of the drilling machine. First, start the operation. Insert yes to continue the operation and no to cancel it. We will proceed to the operation with the yes option. Insert working hours. If it is less than or equal to 8 hours, you can continue to insert the spindle diameter. If the spindle diameter is less than or equal to 81.8 mm, you can insert the spindle speed range to less than or equal to 1700 rpm. Next, insert the spindle speed by less than or equal to 1.2 mm per rev to continue. It will show the drilling depth. The machine will calculate the time and power of the drilling. Next, it will also calculate the hole to drill and the solid waste generated. Then operate the machine as usual and stop the machine when the operation has ended.
For coding part, we need to put the dimensions of blind flanges in the coding to ensure the operator are proceeding with blind flanges by drilling machine. Input 1 will continue the program with blind flanges. Input 2 will end the program with please stop your work now. Next, input for working hours is required. The maximum hours of our drilling machine is 8 hours per day, and if the working hours exceed 8 hours, the program will end with please try again. Then, input for spindle diameter is required. The maximum spindle diameter is 81.8 mm. If we put more than 81.8 mm, the program will end with the value exceed with 81.8 mm. After that, the input for spindle speed is also required, which is the maximum of the spindle speed is 1700 rpm. And if we put more than 1700 rpm, the program will end with the value exceed 1700 rpm and not supported. In addition, for the input of spindle feet is also required, which is the maximum spindle feet range is 1.2 mm per REV. If we put more than 1.2 mm per REV, the program will end with the value exceed 1.2 mm per REV and not supported. And also the drilling depth is required, which is 17.5 mm. And the time and the power used for drilling a hole is calculated using the inputs with formula. Moreover, the number of holes to drill is required to calculate the total time and power used for drilling. Solid waste generated per workpiece, estimated productivity, and estimated solid waste generated of total workpiece and total operation cost with 51 ringgit 60 cent per tariff rate will calculated with formula and showed before the program end. As we can see, the black diagram shows the output of our system.
Conclusion for lathe, milling and drill machine. In conclusion, we managed to collect a few ideas based on the machine used in this group report, which is lathe machine, mill machine and drill machine. Based on the reference, it is stated the lathe is a milling machine with a revolved workpiece and feed cutting tool. The workpiece will be clamped to the headstock or steel stock, which will not rotate in against a stationary cutting tool. Meanwhile, milling machine provide the technology, precision, accuracy, and a constant flow, a procedure necessary for high production rate. They have two characteristics that make them quick with little to no human mistake, which will help us in saving money and time, as well as reduce the chance of having a metal waste. Its operation does not necessitate any trouble. People with the necessary condition, on the other hand, must be in charge to ensure the production runs smoothly day after day. Lastly, drilling machine is defined as a machine that makes a circular hole, a tool that drills the hole of various size and other process that employ drill bill. Thank you.